What's poppin', dogs? Mr. Allen here talking domain of functions and domain of compositions of functions. So we have three different functions here. F of x equals the square root of x plus 1. G of x equals 1 over x. We have a radical and a rational. And we have a quadratic down here. H of x equals x squared minus 25. And then a couple compositions. So for f of x, what's my domain here? Well, let's think about things that you can't take the square root of if we're talking real numbers here. I can't take the square root of negatives, so I want to make sure that this thing is positive. Or can I take the square root of 0? Yes, I can take the square root of 0. So I just want to make sure that I am 0 or positive. How do you do that? Well, if I take the inside part of my radical x plus 1 and I set it greater than or equal to 0, I shall find out. That means it's going to be greater than 0 or equal to 0, meaning positive or 0. So x is going to be greater than or equal to negative 1. So a couple ways you can write this. For my domain, it could be just x is greater than or equal to negative 1. You could go from negative 1 to infinity. That'd be your interval notation. The bracket says you are including that negative 1 because we are, right? We want negative 1 part of that because that makes it 0. So those are a couple different ways you could write it. You don't have to write it both ways, but you should be able to read and interpret either one of these. There's also fancy set builder notation that just gets to be too much. So anywho, those two, I like those. This is kind of like shorthand set builder notation. Your teacher may ask you to do fancy brackets and things. So if they do, make sure you follow their wishes, right? Next one, a rational function, meaning like a fraction, right? So what am I not allowed to divide by? I can't divide by 0. Anything else? Can I divide by negative numbers? Yeah, that's cool. Can I divide by positive? Yeah. Can I divide by fractions and decimal? Yes. The only thing you can't divide by is 0. So here we're just going to say x cannot equal 0. Cool? I think that's pretty straightforward. You could even, if you wanted, you could go from negative infinity to 0, not including, and then 0 to infinity. That's another way you could write this. That's interval notation. I find this to be the easiest, most effective. Again, there's other fancy set builder notation with brackets and a lot of other mumbo jumbo. I think this gets to the point, okay? That's the most efficient. I choose that way when we're dealing with this. Over here, I can go either one, okay? Last one here. H of x equals x squared minus 25. Well, with quadratics, right, it's just like a U shape, a parabola, okay? It's a positive quadratic. Does it ever stop going left and right as it goes up? No, it never stops. So for this one, we got all real numbers, okay? Dope. Or from negative infinity to positive infinity if we'd like. But again, I think the super dope R is the way to go on this one because it just looks cool, right? I got a tattoo of that. I'm just kidding. I don't have a tattoo. Anywho, on to the compositions. G of f of x. What? Well, now we have to take into account both functions. And I find it helpful to write out our composition first. So if we're doing g of f of x, that means f is getting plugged into g. So this is going to be 1 over the square root of x plus 1. Okay. So what can we not divide by again? 0. What can I not take the square root of? Negative numbers. So for this one, I have to think, okay, well, I can't let that be 0. So let's do a little bit of notes here and then we'll formalize it. So x cannot equal, we don't want this to be 0, so negative 1, right? Because negative 1 plus 1 would give me 0, and now I'm square rooting 0, which is fine, but then I'm dividing by 0. That's not fine, okay? So x cannot equal negative 1. Cool. Didn't we also say that inside the square root has to be positive? So really we have to have this. X has to be greater than or equal to negative 1. But we just said it can't be equal to. So how do we combine these two into 1? Well, the way that we're going to do that is just remove the equal to, right? X is greater than negative 1. That is my domain for g of f of x. There we go, right? That does it, right? Cannot equal negative 1. This doesn't equal negative 1. Got to be greater than or equal to negative 1. This is greater than negative 1. Dope. You kind of combine the two, and sometimes you have to think about how you're going to write it most efficient. That's the nicest way. Or, again, with interval notation, it would look like this. Boom. If you're wondering, is there ever a situation where you'd bracket the infinity? No, because you can't get to infinity. So we just leave it as a parenthesis because you never really get there, right? Just keep going. I think that's the justification. That's the one that I use in my head, right? So that's how I always know parenthesis around the infinity. All right, next one here. G of h of x. So yes, this is the same you could write it like this, g of h of x. There's a few different notations for compositions and stuff, and just like adding and subtracting functions, multiplying. There's some shorthand like this. There's where you have the full function notation. So be able to read either one, right? You can write whatever you want unless your teacher has a specific one they want you to use. So again, we're thinking g, okay, so g of h of x. So I got to plug h of x into g. All right, so let's do that. I'll have 1 over, and that was x squared minus, make sure you can see that, 2 minus 25. So that's my new function. Well, I can't divide by 0. So let's figure out what would make my denominator 0 so that we can say, like, no go on that. So I'll set my denominator, x squared minus 25, equal to 0. And I could use square roots to solve this or factoring. I guess I'll add 25. I'll get x squared equals 25, square root, and we get x equals plus or minus 5. Don't forget that plus or minus when you are solving with square roots. Okay, everybody forgets it at some point. Plus or minus with that. You could have also factored this one, x minus 5, x plus 5, difference of 2 squares. You get the same answer. So how do we interpret this as the domain? So you could just say, we got 2 options here, and I'll put it over here in the free space. I've got x cannot equal plus or minus 5. That is one way of writing it. Another way, interval notation. If your teacher chooses interval notation, honestly, I feel like it's very inefficient for this type of problem, but here's how we'd go, and I got to give myself some room. We got negative infinity to negative 5, not including negative 5, union negative 5 to positive 5, and then union 5 to infinity. I almost ran out of room. Okay, so this would also work. Again, I find this method to be this notation, interval notation, to be a bit inefficient when you're dealing with rationals, just because you're just excluding a bunch of values. Inequalities here, totally fine, nice and clean. Ugh. Ugh. I don't know how you guys feel. How do you guys feel? Let me know. How do you feel? Do you like interval notation for this, or are you cool with some shorthand, sort of kind of set builder, informal street math saying x just doesn't equal plus or minus 5? Let's move on, right? I'm voting that one. So anyways, guys, thanks for watching this video. If you have any questions about domain, it is tricky. Algebra 1 through calculus students struggle with domain and range. So if you have any questions, let me know. If you need additional videos, let me know. I'm always here to make some dope vids. All right. Have a wonderful day, guys. See you later.